Hello and welcome to this walkthrough of several practice problems. In this video, we'll break down a variety of SAT math questions, covering topics from quadratic equations to linear functions. Our goal is to equip you with the strategies and insights you need to tackle these types of problems with confidence. Let's get started. We'll begin with the first problem. The question asks, if 2 times z squared equals 12z minus 18, find out how many values of z satisfy the equation. This is a quadratic equation. Our first step is to set it equal to 0 to put it in standard form. First, we'll rewrite the equation. Subtracting 12z and adding 18 to both sides gives us 2z squared minus 12z plus 18 equals 0. This is the standard quadratic form. X squared plus bx plus c equals 0. Next, we can simplify this equation. Notice that all the coefficients are even. We can divide the entire equation by 2, which gives us z squared minus 6z plus 9 equals 0. This looks much simpler to work with. Now, we need to find the values of z that satisfy this. One way to do this is by factoring. We need two numbers that multiply to positive 9 and add up to negative 6. The numbers negative 3 and negative 3 work perfectly. This means our equation factors into the quantity z minus 3 times the quantity z minus 3 equals 0. This can be written more compactly as the quantity z minus 3 squared equals 0. The only way for a squared term to be 0 is if the base is 0. So z minus 3 must equal 0. Solving for z, we find that z equals 3. Because the factor z minus 3 was repeated twice, we call this a double root or a root with multiplicity 2. So, even though it's a quadratic equation, which usually has two distinct solutions, in this case, both solutions are the same. Therefore, there is only one unique value of z that satisfies the equation. Looking at our answer choices, this corresponds to option D. So, the correct answer is 1. Let's move on to the second problem. The question is to calculate a and b, knowing that the following equation has no solutions. This is a linear equation. First, let's expand and simplify both sides of the equation. On the left side, we distribute the 2 and the 5. This gives us 2x minus 2 plus 5x plus 10. Combining like terms, we get 7x plus. On the right side, we distribute the 4 and the negative b. This gives us 4x plus 4a minus bx minus 4b. To make this easier to compare, let's factor out x. We get the quantity 4 minus b, all times x, plus the quantity 4a minus 4b. Now we can set the simplified left side equal to the simplified right side. So we have 7x plus 8 equals the quantity 4 minus b times x plus the quantity 4a minus 4b. A key concept here is that an equation with no solution occurs when it simplifies to a false statement, like 5 equals 7. For this to happen in a linear equation, the x terms must cancel out. For the x terms to cancel, their coefficients must be equal. This means 7 must equal 4 minus b. Solving this equation for b, we subtract 4 from both sides to get 3 equals negative b, which means b equals negative 3. So now we know b equals negative 3. Let's look at our answer choices. Only option B has b equal to negative 3. This means we've likely found our answer. To be thorough, let's confirm the value of a. With b equals 3, the right side becomes 4/3, plus 4a, 4 3, which simplifies to 7x plus 4a plus 12. Notice the 7x on both sides. Subtracting 7x from both sides gives us 8 equals 4a plus 12. Subtract 12 from both sides to get negative 4 equals 4a. Dividing by 4, we find that a equals negative 1. So, our final answer is a equals 1 and b equals 3, which is option B. Next up, we have a word problem involving an equation. The problem describes a gym membership with a one-time fee and a monthly fee, including a discount offer. The goal is to build an equation for the total cost, C over n months. Let's break down the components of the cost. First, we have the one-time registration fee. This was originally $100, but there's a 50% discount. 50% of $100 is $50. So, the registration fee component of our equation is 50. Second, we have the monthly fee, which is $25. Since the membership is for n months, the total cost from monthly fees will be 25 times n. Now we combine these two parts to get the total cost. The total cost C will be the registration fee plus the total monthly costs. This gives us the equation C equals 50 plus 25 points. This equation allows us to calculate the total cost for any number of months, asa n. Let's check this equation against the provided answer choices. Our equation, 50 plus 25n, matches option A perfectly. Therefore, option A is the correct answer. Problem 4 is about identifying lines with the same x-intercept. We're given the equation of a line, 2x minus 3y equals, and we need to find which of the given options has the same x-intercept. Let's recall what the x-intercept is. It's the point where the line crosses the x-axis. At this point, the y-coordinate is always 0. So, to find the x-intercept of our original line, we set y equal to 0 in its equation. Substituting y equals 0 gives us 2x minus 3 times 0 equals 8, which simplifies to 2x equals 8. Dividing by 2, we find that x equals 4. The x-intercept of our line is at the point 4, 0. Now, we need to go through each of the answer choices and find their x-intercept to see if it's also 4. Let's start with option A, y equals 2x plus 8. Setting y to 0, we get 2x plus 8 equals 0. Subtracting 8 gives 2x equals 8, so x equals 4. This is not the same as 4, so option A is incorrect. Now for option B, y equals 3x plus 12. Setting y to 0, we have 3x plus 12 equals 0. Subtracting 12 gives 3x equals 12. Dividing by 3, we find x equals 4. This is the same x-intercept we found for the original line. We've found our answer. Since this is a multiple-choice question, we can confidently stop here. Let's just quickly check one more to confirm our process. For option C, y equals 12x minus 3. Setting y to 0, we get 12x minus 3 equals 0. Adding 3 gives 12x equals 3. Dividing by 12 equals 3/12 or 1/4. This is not the same, so option C is incorrect. The only equation with an x-intercept at x equals 4 is option B. So the correct choice is B. Problem 5 dives into geometry, specifically arc length in a circle. We're given a diagram with a circle, a radius of 6 over pi, and a central angle of 30 degrees. We need to find the length of arc ABC. First, we must remember the formula for arc length. It's crucial to work with radians, not degrees. The formula for arc length S is the radius r multiplied by the angle phi in radians. The question gave us the angle in degrees, so our first step is to convert 30 degrees to radians. To convert, we multiply the degree measure by pi over 180. 30 times pi over 180 simplifies to 30 pi over 180, which reduces to pi over 6. So our angle in radians is pi over 6. Now we have our radius r and our angle theta in the correct units. We can plug them into the arc length formula. Let's substitute our values into the formula S equals r times theta. Our radius r is 6 over pi, and our angle theta is pi over 6. Notice what happens here. The pi in the numerator and the pi in the denominator cancel each other out. Similarly, the 6 in the numerator and the 6 in the denominator also cancel. This leaves us with S equals 1. The length of arc ABC is 1. Comparing this to our answer choices, we see that 1 corresponds to option C. So the correct answer is C. Problem 6 deals with absolute value inequalities. The question asks for all possible values of z. If the absolute value of the quantity z minus 1 is less than 3, when solving an absolute value inequality of the form x k, we use the rule that it's equivalent to the compound inequality k x dk. Applying this rule to our problem, we treat z minus 1 as x and 3 as k. This gives us the inequality. Negative 3 is less than z minus 1, which is less than 3. This inequality is read from left to right. It means that z minus 1 must be between negative 3 and 3. To solve for z, we need to isolate it in the middle of this three-part inequality. We can do this by performing the same operation on all three parts. Since z is being subtracted by 1, the opposite operation is to add 1. So we add 1 to the left, middle, and right parts of the inequality. Let's calculate each part. Negative 3 plus 1 is negative 2. In the middle, negative 1 plus 1 cancels out, leaving just z. And on the right, 3 plus 1 is 4. This gives us our solution. As is between negative 2 and 4. In other words, Diaz is greater than negative 2 and less than 4. Comparing this result with the given answer choices, we find that it matches option D perfectly. So the correct answer is D. Our final problem involves interpreting the graph of a linear function and its transformation. We are shown the graph of a line, y equals f of x, and we need to find the x-coordinate where the graph of y equals f of the quantity x plus 2 intersects the x-axis. First, let's understand the original function. The graph of y equals f of x is a line that crosses the x-axis at x equals 2. This means its x-intercept is 2. Remember, the x-intercept is the x value where the function's output is 0. So, from the graph, we know that f of 2 equals 0. Now, let's consider the new function, y equals f of the quantity x plus 2. This is a transformation of the original function. Specifically, the transformation f of x plus k, where k is positive, represents a horizontal shift to the left by k units. In our case, k is 2, so the graph is shifted 2 units to the left. We want to find the new x-intercept. This means we want to find the x value where f of x plus 2 equals 0. We are looking for the x value such that f of the quantity x plus 2 equals 0. We already know from the original graph that f of 2 equals 0. Let's compare the inputs. If we know f of 2 is 0, and we want f of x plus 2 to be 0, it must be that the input to the function x plus 2 is equal to 2. Solving the simple equation x plus 2 equals 2, we subtract 2 from both sides to find that x equals 0. So the new x-intercept is at x equals 0. This makes perfect sense. The original intercept was at 2, and the graph shifted 2 units to the left, which lands us at 0. Looking at our options, x equals 0 corresponds to option B. So the final answer is B. And that concludes our walkthrough. We've tackled a variety of problems, reinforcing key concepts in algebra, geometry, and functions. Remember, the key to solving these problems is to break them down, apply the correct formulas and rules, and pay close attention to detail. Keep practicing, and you'll build the skills and confidence to succeed.